Okay, here we go. We're doing UMSL number 4, uh, quadratic solving. So I'll try to make this really quick. What does it mean when we solve a quadratic? And let's think about that as we work. Well, let's talk about what it means to solve a quadratic. Basically, when we're setting a quadratic equal to 0 and we're solving, we're actually finding the x-intercepts, right? We're finding out where that parabola, when we graph the quadratic, where it crosses the x-axis. So that's what we're actually solving. So there's a couple different methods to solve quadratic equations, and the first one's the square root method. If you see an equation set up like this, it's super easy to just go ahead and say, well, let's take the square root of both sides, right? I have this whole thing being squared, and that tells me that I can just go ahead and take the square root, which will undo this square right here. Now, let's pause for a second. Anytime we take the square root of both sides in an equation, what do we have to tack onto the right side? That's right, we got to put that plus or minus. So let's see, we end up with x plus 4 because the square root undoes the square, and then square root of 49 is 7, so we'll have plus or minus 7. So what we have here is an equation with two parts. We can have either x plus 4 equal positive 7, or x plus 4 equal negative 7. So we're going to split them apart so we can see what our two answers are. Here it's going to be 3. Here it's going to be negative 11. So that means if we would have graphed, well, if we would have got the 49 over on the right side and then set it equal to 0 and, graph the whole thing, these would be our x-intercepts. All right. So here we go. Look, we could do the quadratic formula, except for we have to divide by 36 first. Oh my goodness. We're not doing the quadratic formula first. I'm probably going to say some silly things because I'm sleep deprived because my new grandbaby is here. All right, we can't do the square root method until we get rid of this 36. And the only way to get rid of the 36 is divide both sides by 36. So we have x minus 8 squared. Oh gosh, how many times does 36 go into 144? Does it go in 4 times? Yep, that sounds good. And now we're just doing exactly what we just did in the last problem. Square root of both sides, put that plus or minus in front. So we end up with the x minus 8 equals plus or minus 2. So 2 problems, right? 2 problems in one. And that is x minus 8 equals 2. X minus 8 equals negative 2. So we get x equals 10 and x equals 6. Woo! All right, we're going to fly through this, and hopefully I don't make too many more mistakes. All right, so solve by factoring. So when we see, this is a trinomial, right? We see 3 parts, bloop, bloop, bloop. And when we see this and we have a quadratic, we can go ahead and set up our parentheses. And when we set up our parentheses, we're saying what times what is going to give me, what times itself is going to give me x squared? Well, x times x. Now that's what we put in here. Then we say what times what gives me 10? I have 2 options, right? I have 1 and 10. I have 2 and 5. So I have to pick one or the other. How do I know? I look at this number 7 because whichever one I pick, sure, when you multiply them, they have to equal 10, but when you add them, they have to equal 7. So the winner is, ding, 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 here, 2 and 5. So we'll put a plus 2, a plus 5. If you don't believe that that's really true, then go ahead and distribute these 2 binomials, and you'll get right back to this trinomial. All right, so let's go ahead and keep going. Now we have something times something equals 0. And so think about it. If you have 2 numbers that you know, if you multiply them together, they equal 0. Well, you know either one or the other has to equal 0. And that's what we do. We say, well, either x plus 2 equals 0, or it could be x plus 5 equals 0, or both of them, right? And so we go ahead and solve, subtract 2 from both sides, and we get to our answer. There we go. We are solving quadratics by factoring. Boy, I'm flying through, aren't I? Okay, where'd my problem go? Here we go. Solve by factoring. So now this one's a little bit harder because we have a minus and minus, so we're just going to have to think a little bit more, right? We still have that x squared in the front, so we're going to have the x and the x. Let's come over here and think about, well, we only have 1 and 21. and 3 and 7. So we know which ones we're going to use, right? We're going to use the 3 and the 7, but now we have to figure out where does the plus go, where does the minus go. Well, I have two options, right? 3 minus 7 or negative 3 plus 7, and I want to get a negative 4, so I'm going to pick this combination. I'll put the positive in front of the 3, the minus in front of the 7. If you don't believe me, go ahead and distribute, and you'll get right back to it. But now it's time for either x plus 3 equals 0 or x minus 7 equals 0. So we'll have x equals negative 3 or x equals 7. We get our two answers, and we are good to go. Woo! Let's keep going. All right, let me check my time. My fear is that I'm going and it's not recording, but it is recording. Look at that. All right, so let's go to the next one, solve by factoring. Oh no, we've got the 6 in the front. All right, we got to think a little bit more. All right, so we can do a 3x and a 2x, right? Or let's give us a 2x and a 3x so we can kind of mess around with different combinations. I know some of you do a different method. I use guess and check. It works for me because it's not really that bad. So I have 4 different arrangements that I can use with looking at this 6. All right. Now I think about the 4. Now what I need is I'm either going to use 1 and 4 or 2 and 2. And this is where experience starts to, you can eyeball things. And I'm like, okay, I somehow need to get a 14, right? If I put a 2 and a 2 here, that is not going to work. That is going to give me what? So what I'm doing, you can't see me pointing, but I'm looking at this and this, right? Give me a 6x. This gives me a 4x. Okay, so that's going to give me a 10x. That's not going to work. So I know that that's not going to work with 2 and 2. And so what I'm going to do is go down to some of the bigger ones and let's put a 2 and a 2 here. This gives me from here to here. That's my 12x. That's my 2x. Ding, ding, ding. That's my 14x. So let's go ahead and get rid of those lines so that we can see. I'm going to put a plus and a plus. And let's go ahead and say this is going to be my answer here, except for, whoops, I got to solve. So let's go ahead and set that equal to 0. I've got 6x plus 2 times x plus 2 equal to 0. So I'm going to have 6x plus 2 equals 0. And x plus 2 equals 0. So what am I going to get? I'm going to get 6x. I'm going to extend the page. 6x equals negative 2. So x equals negative 1/3. And I'm going to get my x equals negative 2. Hopefully I didn't make a mistake. If I did, good for you for catching it. And sorry I can't hear you through the video. Where'd my problem go? All right. Example from Delta Math. All right, so here we go. You're going to be obviously doing Delta Math. Your test is on Delta Math for this unit. So this looks different because we have something on that side. So let's get rid of it. Let's go ahead and subtract 6x from both sides. I like to put it underneath the term that I'm going to be combining it with. We only do it once. We don't like subtract 6x from 3x squared, subtract 6x from negative 5. No, we just do it once, right? And so what do we have? We have 3x squared plus 14x minus 5 equals 0. This one is going to be easy because this is a prime number, right? So only 3 times 1. This is a prime number, so only 5 times 1. So this should be easier to factor. So I can keep my speedy speed. Oh, I am tired. All right, let's put 3x. Let's put x. And our choices are, we either put the 5 with the 3x or the 5 over there. I know I'm going to put the 5 here because then outside times outside gives me 15x. I'll put the 1 here. That gives me 1x. So I want a negative means one of these has to be plus, one of these has to be minus. But this plus 14 tells me I better put my plus here because then, right, my outer times my outer gives me a positive 15x. We put my negative in here. My inner times my inner gives me a minus 1x. So that gives me a 14x. All right, here we go. We got 3x minus 1 equals 0. We have x plus 5 equals 0. And so for Delta Math, we have what? X equals 1/3 and x equals negative 5. Don't you dare turn that 1/3 to a decimal. All right, I know you wouldn't even think about it. All right, let's keep going. What does this say up here? Is this still Delta Math? Oh, factoring. Okay. Oh, darn it. Now we only have a binomial. So this is not a trinomial. We cannot set up our 2 parentheses. But one thing we can do is we can notice that we have some common, we have a greatest common factor, right? We have some common factors. What's the biggest number we can pull from 3 and 12? Well, 3, right? What's the biggest x we can pull from x squared and x? Yep, just x. We can't pull x squared because this guy is only on x. When we're pulling, we're actually pulling the number that's greatest in both of them, or the x that's greatest in both of them. So the greatest that we see here is just plain old x, okay, that they both have. This one has the x squared, but this one doesn't, and we're picking the greatest one that they both have. All right, so what's left? 3x squared, if I factor out a 3x, you know how when we distribute, we're multiplying. When we factor, we're actually dividing. So we're just going to divide by this 3x that we're taking out. X's go away. X squared over x is x. Same thing, we'll do the 12x divided by the 3x. X's go away, we end up with 4. Some people don't do it that way. Some people just go, what should I put here so that 3x times x gets me back to 3x squared? What should I put here? So 3x times 4 gets me, or 3x times whatever I put in there gets me back to 12x. Whatever method you use, I am fine with. All right, let's keep going because I'm trying to break records here apparently. 3x equals 0, x plus 4 equals 0. So we divide by 3, so x equals 0, x equals -4, and hopefully I did not make mistakes. I'm doing this real quick because I'm going to be out for this lesson, and I looked at the pacing guide and I realized, oh my gosh, I've got like a million videos there for you, and that doesn't seem fair. Let's just do something that matches the notes in your packet. Why not? I gave you them, so okay. All right, I'm quit talking. I'm going to distract myself even when there's no students in front of me. All right, completing the square, because we note that I can't factor this. This is not factorable. You know, I can't, 7 times 1 equals 7, but 7 plus 1 is not equal to 10. So here we go in completing the square, and maybe, just maybe, I'll slow down just a little bit. All right, here's what we're going to do when we complete the square. We're going to kick this 7 out. All right, that's the first thing we're going to do. We're going to go ahead and say, 7, you are not working for us. We are going to kick you out on the other side. So we're going to subtract 7 from both sides, right? We're going to subtract 7 from both sides. And we're going to leave this space right here. I don't know, I feel like pink right here. We're going to leave this space because we're going to put something in this space. Now, what are we going to put in this space? Well, what we're going to do is we're going to come over and we're going to look at this number. We're going to say 10. We're going to do some work on you. We're going to say 10, and then we're going to divide it by 2. And then we're going to times, so 10 divided by 2, that's 5. And then we're going to take 5 and we're going to square it. It's like it goes through this machine, and then that's what we're going to put. We're going to put a plus 25 right in there. All right, so what did we just do? All right, now that I know that you've done completing the square before, but you're going to do the same thing every single time. You're going to take the middle number, you're going to divide it by 2, whatever that number is, you're going to square it. All right, and then that number goes into that box. All right. What we just did was we created what's called a perfect square trinomial. And if you're wondering, well, what does that mean? Watch. If we factored this, look what we get. Wait a second. I know somebody somewhere watching this video is going, wait a minute. You just plopped in a 25 on the left side. You better plop in a 25 on the right side. And you are so right. We got to keep this equation nice and equal, don't we? All right, so back to factoring. Here we go. Let's get the orange back out. So let's go back to factoring. We're going to do what times what equals 25, but adds up to 10? Well, we know 5 and 5, and we're like, oh, that is special. Ooh, let's go ahead. 25 minus 7 is 18, right? Okay. So let's see. What are we going to do now? So this is special because there's another way we can write this, right? Can't we write this like this? And when we write this like that, oh my gosh, look what we've got. We've got something we can solve with how we started this video, the square root method, right? We can go ahead and take the square root of both sides, plus or minus square root, okay? And then let's get the orange back. So then we end up with x plus 5 equals plus or minus the square root of 18. Now we have not done radicals yet, that we're going to do that this next unit. Now, if you remember how to simplify radicals, you go for it. Otherwise, pick up your calculator, put square root of 18 in, and hit enter, and it should go ahead and give you what? 18 is 9 times 2, square root of 9 is 3. It should give you 3 square root of 2. because I'm pretty sure that delta math is going to expect you to simplify your radicals. So we'll still have plus or minus 3 root 2, but once again, you have your calculator, you can do that. We're going to subtract 5 from both sides, and so what that's going to look like is x equals negative 5 plus or minus 3 root 2. Now in delta math, you'll probably have to split it up. You'll probably say negative 5 plus 3 root 2, comma, negative 5 minus 3 root 2. Unless they have that plus or minus button, I don't know. All right, yay, we completed the square. Okay, again, do we have to? All right, I am not going to complete the square with a number in front of my x squared because we can't. We have to have nothing there. So what we're going to do instead is note, every term is divisible by 2. So let's go ahead and let's get pink. Or no, let's get, that bluey gray is really pretty. Let's go ahead and get the 2 out. And then we're going to go ahead and have this. Let's get rid of this pesky 2. If we divide both sides by 2, do you agree it just goes away anyways? And then 0 divided by 2, 0 divided by 2 is 0. Can we factor this? We cannot. So let's go. We're going to be good at it. We did it once. All right, let's kick the negative 4 out. That means by adding 4 on both sides, right? So we'll get a 4. We're going to leave that pink box open, and we're going to do a little surgery to the 8. We're going to take the 8. We're going to divide it by 2. That gives us 4. We're going to take the 4. We're going to square it. That gives us 16. So we're always doing what? We're always dividing by 2 and then squaring. So we're doing, the 2 is really active in this surgery. This is terrible, me saying it's a surgery. All right, so I'm going to add 16. By the way, since we're squaring it, this number that we put in here will always be a plus. And we're going to add 16 to both sides because we got to keep our equation an equation. So now look at this. We can factor this. What times what equals 16 and also adds to 8? Well, that's 4 and 4, right? All right. And so then we're like, we can write this way better. And now we get to use square root method, and we are so good at that. Let's go ahead and pull orange out because that gray and orange will really pop. Let's go ahead and do plus or minus. Well, you know, and if it's a little bit more pumpkin-y, I think. All right, so we'll have x plus 4, and we'll have equals plus or minus root 20. If you remember how to simplify, you can do it by hand. Root 20 is the same thing as 4 times 5. That's the same thing as square root of 4 times square root of 5, which is 2 root 5. If you don't remember that, just use your calculator because we will be going over that next unit. So we'll have plus or minus 2 root 5. We're going to subtract that 4. And then once again, split it up if you have to for delta math. Woo! We're doing good. How come my problems don't show up on the first time? Solve using the quadratic formula. Oh, thank God, I finally get to sing. All right, so for real, quadratic formula, I do sing it, and I encourage you to sing it as well because that's how I remember the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Man, I started really low there, didn't I? I literally sing that. So do you have to have this memorized for the test? Yes. So if I were in class with you, we'd be singing along. And now you're like, wait, what are A's? What are B's? What's going on here? So if you remember from last year in algebra that whatever's in front of your x squared is your A. So we don't see anything there. That means there's a 1. Whatever's in front of your x is your B, right? Whatever's your constant is your negative 8. That's your C. And you just plug and chug. All right, so let's plug and chug. Let's do that. That's maybe a little bit more Halloween-y. All right, so we've got x equals, b is 10, so negative 10 plus or minus square root 10 squared minus 4 times 1 times negative 8. All right, all over 2 times 1. I don't have my calculator up here, so let's see what I'm going to do. What I always focus on is I hit my calculator and I do this part first. All right, so let's see, 100 plus, that's going to be 132. So that's square root of 132. Okay, all over 2. 132, I'm sure 4 goes into that, right? I don't want to make this video any longer. Well, all right, should I? Let's divide 4. I should have brought my calculator up here. So that'd be 3, 12, 12, 33. All right, so this is going to be x equals negative 10 plus or minus. We've got 2 root 33 all over 2. And you'll notice, oh, this is all divisible by 2. All right, so I'm just telling you this just in case you see it on Delta Math. As long as you do the same thing to every term you see, you're not breaking any laws. So if I divide negative 10 by 2, I'll get negative 5, and then of course the plus or minus. If I divide this by 2, I just get the root 33, and if I divide this by 2, I get 1. So I'm not even going to write the 1 because divided by 1 is just this. All right. Whew, how many more do we have? What's our time? Let's see. I know I'm setting all kinds of records and it's still 20 minutes. All right, so here we go. What is this asking us to do? Quadratic formula. All right, this is just, look, A equals 1, B equals, drum roll, 0. Okay, that's the hard part about this. I am not going to keep doing this. You all can do it. Actually, you know what? I need to do it. But anyways, I'm just done, as are you, I'm sure. So if you don't see an x, it's because the number in front of it was 0. So let's see. X equals negative b. Nice one, b is 0. Plus or minus square root b squared minus 4ac all over 2a. All right, here we go. Oh, this is going to be really fun. It's going to be really fun. So if we put this part into our calculator, we're going to get domain error. And domain error just means like an x doesn't exist there. And so to understand why, actually just put this part into your calculator. And when you put this part into your calculator, you see that you get a negative 20. So square root of negative 20, we know that's an imaginary number. And our calculator is looking for real numbers, not imaginary ones, all right? So what does that mean? It means there's no solution. So what does it mean when a quadratic doesn't have a solution? Well, real quickly, we can have some fun and see that this, if we graphed it, right, we know transformations. This is a parent function, right, parent function, but it's raised up 5. If I'm raised up 5, let's get pink, because I don't know, pink's so pretty. If I raise up 5, look at that. And is this pink quadratic ever going to cross through this x-axis? No, there's no solutions. Because, right, that's when we're solving a quadratic. That's what we're looking for. Where does this graph cross through the x-axis? And the answer for this one is never. All right. Oh, gosh. Let's see. What does it say? Solve the following systems algebraically. All right. We're going to have to use substitution here. We can't use when we have two linears, we can use elimination, right? We can use substitution, but when you have a linear and a quadratic, you only get to use substitution. So here I see that y is the same thing as 3x minus 5. So that means when I see my y, I'm going to plug in 3x minus 5. It's the same thing according to this equation. So I'll have 3x minus 5 is equal to x squared plus 6x minus 33. And I'm going to go ahead and get the 0 there. So I'm going to subtract the 3x from both sides. And I'm going to add the 5, right, to get that 0. Okay, so I end up, ooh, this is just very, very, very messy. All right, let me, not only that, like, come on, purple, this was pretty, wasn't it? All right, so let's say we have a 0 on that side, and then we have the x squared plus 3x minus 27. Does that sound good? No, that should be 28, shouldn't it? All right, 28. Don't trust my math. All right, so 28, and so let's see. Oh, this will work, right? 28, 7 times 4, so we can actually factor it. So we'll have a plus 7 minus 4, and we're going to go set this all equal to 0. So we get x equals negative 7 and x equals 4. What does our answer mean? It means if we went ahead and graphed this quadratic and graphed on the same graph this line, this is where they would meet. Oh, wait a minute. Does it ask? Okay, so now if it asked me to find the points, what I would do is I'd go ahead and plug the x back in. So I'm not sure when you see this on Delta Math, if it's just asking for the x values, but let's go ahead and find the points anyways. I'm going to plug them back into the y equals 3x minus 5. So let's see, y equals 3x minus 5. So for the negative 7, y is going to equal what? Plug the negative 7 in. So y is going to equal negative 21 minus 5, so negative 26. So if Delta Math is asking for the actual points, you want to put that point in. And then for the x equals 4, that would be what? Y equals 3 times 4 minus 5. 12 minus 5 is 7. So that is 4, 7. All right. And so that would be where the 2 points where these two intersect. Please tell me that's our last one. Oh, thank God. That's our last one. All right. It says Delta Math UMS review, not so fast. There's so much more. So we're doing whatever the Delta Math is next. I don't have actually I do. So it should be what? UMSL number 4. And hopefully I remember to open that for you. All right. Love you all. Miss you. Have fun with this math. See you later.